Write IUPAC names of the following compounds. Wow. We have CH3CH double bond C, CH3, hold twice, CH3CH, CH3CH double bond C, CH3, CH3. Let me draw the bond line notation so that naming becomes easier, and let me again invite you to recall the rules of nomenclature, because as I suggested, these are not simply answers which we are presenting to you, but also the methods, and using these questions as excuse, we will again make you revise the essential theory. So what are the rules? The rules say that first of all, you are supposed to choose the longest possible carbon chain. Now, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. CH2 double bond C. I'm sorry. I'll just draw this again. Double bond CH, C, 1, 2, 3. Triple bond C. And then I have CH3. A molecule like this, and this is already a bond line notation. Now what do? I choose the longest possible carbon chain. Well, that would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Whichever case you take, that chain looks like this only. Okay. Now from which end should I begin to count? Having chosen the correct possible carbon, longest possible carbon chain, every chain has two ends, and I have to start giving numbers from one end, 1, 2, 3, 4, or opposite 1, 2, 3, 4. Let me try 1, 2, 3, 4. This is one way of numbering it, the black way, and there could be, well, a red way. Red way is 1, 2, 3, 4. What is correct? The second rule says, are there double or triple bonds? Check. Yes, there are. If there are double or triple bonds, then you must choose them in such a way, you must number them in such a way that the double or triple bond gets the lowest possible locant or number. The black side, 1, 2, the double bond gets number 2. And the red numbering, 1, 2, again the double bond gets numbering 2. So whether I count it from this end or that end, double bond again gets a number 2 only, so it appears like 2-butene always. Is there any other rule? Yes, then there is a third rule, which says that if first and second points are the same, then look at the branching. Whichever side has earliest branching or earliest substituent or earliest point of difference, choose that. The earliest point of difference, if you say 1, 2 and there's a branch, 1, 2 and there is no branch. On the black side, there is a branch of methyl at 2. In the red numbering, there is no branch at 2. So black is better as compared to red. So I would say that no, that red numbering is not as good. I'll just get rid of that. The black numbering, the black is beautiful, of course. We will just write it down. 2-methyl butene. 2-methyl butene. Why bute? 4 carbons. So root is bute. Alkene, that is why ene. Alkene appears on number 2, that is why butene. 2-methyl butene, and that is, my dears, the IUPAC name of this lovely compound. What about this one? Actually, there is only one chain. So there is no confusion when it comes to selecting the chain. From which side should I number? From this side or that side? Whichever has earliest appearance of multiple bonds, that side should be chosen. So 1, 2, 3, 4 and 5. This is, my dears, the way we choose it. And then 1, 2, 3, 4, 5. Now this is 5 means penta. Yeah, pent. So this is pentinine, ene and ine. So this is pent 1 ene 3 ine. Pent 1N 3 ine. This, my dears, is the way we write it. C. What is the longest possible carbon chain? Well, this seems to be the only carbon chain. 1, 2, 3, 4. It is same both the ways. So it is butadiene. Why there are two alkenes? So di in the butadiene. But alkene happens at 1 and 3. So 1, 3. Butadiene or buta 1, 3. Diene. Both are correct. You can write it whichever way you like. 1,3-butadiene or buta 1,3-diene. All, either of them is of course the correct number. Then D. Oh my God, what should I do? Well, carbon chain can well be chosen. 1, 2, 3, 4. And then what do I say? I would say this is butene, yes. The 4-phenyl, because this group is called phenyl. This is phenyl. 4-phenyl but 1-ene. 4-phenyl but 1-ene. Phenyl group can be very conveniently chosen as a substituent. So, don't be impressed by the fact that this is a ring and there are 3 pi bonds. It's okay, it's there, very nice, but this is as well as, a very good name. What about this? In this case, there are 2 substituents on the benzene ring. So benzene ring should be chosen as, please remember this is benzene. Don't call it 1,3,5 cyclohexatriene. It is actually benzene. It has a special status. 1 and 2. Wow. So what is this? I hope you can see this 1 and 2. 2-methyl benzene 1-ol. Benzenol, yes. Or if you want to be stylish, you could also write it as 2-methyl phenol. Why? Benzene 1-ol is also called phenol. So, a very accurate IUPAC name is this. But as a minor possibility, 2-methyl phenol, this also could have been the name, or even if you stoop down to a common name, O-cresol. What are cresols? Cresols are molecules in which on one benzene ring there is one methyl group and one OH group. And if they are adjacent to each other, it is called O-cresol. 1, 3 M-cresol and 1, 4 P-cresol. But that, my dears, is a common name. That is not, of course, the IUPAC name. This is just a common name, albeit a very popular common name. What about the next ones? Let's take a look. Oh my God, what is this? Let's draw bond line notation and then let's take a look. CH3, CH2 whole 4 times. 1, 2, 3, 4. 1, 2, 3, 4. So I have methyl and 4 methylene groups. And then I have CH. And that group now divides into 2 portions. I have CH2, CH2, CH2 3 times and then methyl. CH then CH2, 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 CH3. CH2, 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 CH3. This is that carbon we are talking about. This one. Right? What about this? CH2. Then again I have CH. Then I have CH3, CH3. Oh my God, so ugly. Whatever. Just check it once again so that you are sure that you have not made any mistake. CH3, fine. And then you have 4 CH2. 1, 2, 3, 4 CH2. And then you have CH with a dot. CH with a dot. I've just put a heavy dot so that you can, reconcile and check. Otherwise, this heavy dot is not needed as a part of standard IUPAC stuff. We just have to name it. Also, what is the longest possible carbon chain? Well, very clearly, this looks like the longest possible carbon chain. Yes. This dotted line is not very nice. I'll just, I'm trying to change it over to a highlighter. Let's see. Longest possible carbon chain. I'm just trying to highlight that for you. Yes, I think this is much cleaner. Yeah, I like it. So, this is the longest possible chain. How do we number it? We start numbering it from the side wherever earlier branch appears. 1. If I count it from here, 1, from here 1. 2, 3, no branch. 4, no branch. 5, there's a branch. This side, there is a branch on 5 number. If I count from this side on 5 number, there is no branch. If I count from this side on 5 number, there is a branch. So accordingly, I must say, numbering must begin like 1, okay, and then 2, 3, 4, 5, 6, 7, 8, 9. Oh my God, there are 10 carbon atoms. This is decane. Yes. Which group is this, by the way? If you just get to see 1, 2, 3, 4, there are 4 carbon atoms and the ending is branched. This is isobutyl group. Wow, this is isobutyl? Yes, this is isobutyl. Now, how do I write this? I'll just write the name. We'll write it. Let's do that. So, this is 5 isobutyl decane. 5 isobutyl decane. That's it. That's it. That's the name. If you're not happy with this, there is another method. If you don't want to use these common names accepted in IUPAC, there is a method of side chain nomenclature. See, this is the side chain. If you care to note, this is a side chain. Yes, quite true. Very stark indeed. Now, this atom which is attached to the main chain, this atom which is attached to the main chain, we will say this is 1 dash, 2 dash, 3 dash. That means this side chain will be named as propyl. Okay. So instead of isobutyl, I can call it 2-methyl propyl. So 2-methyl propyl. Why do you put dash? Just to make sure that we highlight the fact that this numbering is not the main chain but the side chain numbering. And this entire group is present on number 5. So you can call it like this. 5 2 dash methyl propyl, and the entire thing is what? The entire thing is decane, so that it should be called decane. I don't like dashes. If you say, then there is a third offering also by IUPAC. They say you can put this in bracket 5 2 methyl propyl decane. If you are enclosing the side chain in a bracket, then you don't have to use dashes. The moment you are numbering within brackets, it means that it is the numbering of side chain. So 1 or 2 or 3, each of them is the correct IUPAC name. Don't you forget. And let's look at G. Oh my God, this is so heavy. I have enormous carbon chain, and needless to say, this carbon chain itself would be the parent carbon chain. This, my dears, would be the main chain. If this is the main chain, from which end should I begin to number? 1, 2, there is a double bond. 1, there is a double bond. Whichever side gives you earliest double bond, from that side you must number. In that case, we are really not worried about the side chains. The higher priority is taken by the double bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is again decane. It's not ane. 1, 2, 3 double bonds. So this is trine, decatrine. Deca, 1, 5, 8. 8 trine. It is decatrine, but there is a side chain. There is ethyl. So this is 4 ethyl. 4 ethyl deca 158 trine. That's it.